Math 3, semester final review, unit 3. Okay, so we're going to talk about factoring. We should remember a little bit of this, but going back to factoring sum of cubes, okay, and differences of cubes. So the first thing you always need to do with cubes is what? Yeah, make sure that you write every single term as a cube, okay? And so 27 we would write as what?
3.
Good. So we have 3 to the third, x to the third plus, and then 64 is 4 to the third. Okay, your first parenthesis is always, if you look here, you just take off all the cubes. So once everything is a cube, the cubes go away, and then we just have 3x plus 4. Now, the second parenthesis is where we talked about how we could write out. So because there's 2 terms right there, you would write that as 3x times 3x times 3x, and then 4 times 4 times 4. Okay, because there's 3 3x's and there's 3 4's. Okay, and so remember that the first term in the second parenthesis is the first 2 multiplied together. So that makes
9x.
good. And then your second term is the 3x times 4, which is 12x. But remember, we always have to do the opposite sign. So if this was plus, then here this is going to be minus. Good. And it's always going to be that way where it's the opposite sign. And then the last term is 4 times 4, which is 16. Okay? And so when you look at your answer, there's only one minus sign. Okay? Whether it's adding if it's sum of cubes or differences of cubes, either way. And if you look here at the examples here at the top, see how this one only has one minus sign because the opposite of a minus is a plus, and this one's always positive. Same thing here, there's only one minus sign. Okay, so that's another way you can go back and double check. All right, so B. I'm going to give you about 30 seconds to try to factor that one on your own. Okay. Yes.
No.
Are you sure?
Yeah.
Okay, so 125, how is that as a cube?
5.
Okay, and then we have x cubed minus an 8 would be
2.
2 cubed. So don't forget to write everything as cubes, because sometimes someone will keep this like as an 8, and that will mess everything up. Okay, so they all have to be cubes. So first parenthesis then will be?
5x.
5x.
Good. Okay, so now for the next parenthesis, this is when we can write it all out. Now since that's the first term, each of those is 5x, right? So we have 5x 3 times, and then 2 3 times. Okay, and so I'm just going to group these right now. So that's my first term, second term, third term. So first term will be what?
25x squared.
Good. Okay, my next term will be
10x.
10x, will be plus or minus?
Plus.
Good. Okay, and then the last term will be
4.
plus 4. Okay? Any questions there? All right. Okay, next problem. Okay, it says write each function in completely factored form over the integers. Find all the roots, real and imaginary, with their multiplicity if different from 1, and then how many x-intercepts does the function have? Okay, so anytime you have an answer that's imaginary, and how do you get imaginary numbers?
There's a negative under root.
Negative under a root. So while you can get that answer with the imaginary numbers, it's not actually a point that it's going to be on the graph. So those wouldn't count towards your x-intercepts. But any answer that's not imaginary is an x-intercept. Okay? And then remember how, like, if you have a term, like, let's say we ended up with x plus 3 squared. Okay? Well, the answer for that would be x equals negative 3. But that would have a multiplicity of 2 because there's 2 negative 3's, but you wouldn't actually put 2 negative 3's on a graph. Are you with me? Okay. So when we're graphing, or sorry, we're going to start by factoring this. How do you factor with a fourth power like this?
By crying.
Okay, so if you look, this is still a trinomial. Okay? So we're still figuring out what adds to be negative 5 and what multiplies to be negative 36. The only difference is remember when we have x squared here and a plain x here, we do x and x. Well, if you have x to the fourth and x squared here, instead of putting an x in the front of each parenthesis, you're just going to put an x squared in the front of each parenthesis. Okay? So what two numbers will work?
9 and 4.
9 and 4.
Negative 9, positive 4.
Perfect. So when I write this, it's going to be x squared minus 9 and x squared plus 4. Is that okay? Okay. Now, can either one of those factor further?
Yes,
Which one?
The
both of them.
x squared minus 9.
Only x squared minus 9 because it's a difference of squares. We can't factor sum of squares. We can factor sum of cubes, but not sum of squares. This will not factor. Okay?
Well, I wrote it down for negative.
Well, you wrote it down wrong. Okay, x minus 3, x plus 3, and x squared plus 4. I'm sorry.
It's okay.
Okay. All right, so when we are solving these, okay, this answer, when we set it equal to 0, will be x equals what?
Negative 3.
3. Good, depending on how you wrote it. The next one will be x equals negative 3. Now, on this one, when we set it equal to 0, and maybe we should write this one out, x squared plus 4 equals 0, what would I do?
Subtract.
Good. Subtract 4 to both sides. X squared equals negative 4, and then what? Good. Take the square root, and remember that anytime you take a square root, it makes it what?
Plus or minus.
Plus or minus. So that means I'm going to have
Actually, it's plus or minus 4.
Plus or minus 2.
Imaginary 2?
plus or minus 2i. Good, because that negative would come out, and you'd write it as an I, and then you can break 4 down to 2 and 2. Okay? So we get plus or minus 2i. So, this was my answer for A. Okay. These are my answers for B. We have negative 3, positive 3, plus or minus 2i. And then C says, how many x-intercepts do you have? So how many would you say? 2. Good. Because the imaginary numbers don't count. All right? Is that good? Okay. Let's move on to D. So what two numbers multiply to be negative 100 and add to be 99? Good. And so when we write this out, it's going to be what?
X squared plus 100,
Good.
and then x squared minus 1.
Good. Okay, can either one of those be factored further?
No.
X squared minus
Yes,
1.
x squared minus 1.
Good. X squared plus 100, and then x minus 1, x plus 1. Okay, so that right there is my answer for A, because it wants the problem factored completely. Okay, B, this is when we solve for them. So x squared plus 100, we set that equal to 0, and I'm going to get x squared equals negative 100. Are we okay there with me skipping a little step? So we'd set it equal to 0, subtract 100 to both sides. Okay, in order to get rid of a square root, I mean a square, I take the square root. Okay, and we get x equals plus or minus, what's it going to be? 10i. Good. Okay, because we take the negative out, which becomes an I, and then 100 breaks down to 10 and 10. And then my next one we get is x equals 1, and then x equals,
Negative 4.
good. And so how many x-intercepts do I end up having for this problem?
2.
Very good.
Will it pretty much always be like that?
You mean 2 being the, no. It just depends on how the factors work. Okay? All right, E. Find all the zeros for this function if x minus 4 is a factor. Now, anytime they tell you like x minus 4 is a factor, it is best to use your synthetic division. Okay, so when you're using our synthetic division, if this is minus 4, the number that we put in the little box is a positive 4 because we had set x minus 4 equal to 0, okay? And then we just write the coefficients of each of these numbers. You want to make sure it goes down in order 3, 2, 1, and 0, because if not, you put a 0 in the place. Your homework and everything, you don't have to worry about plugging a 0 in, okay? So the numbers I would write would be 1, and then what? Negative 7, 2, and 40. Okay, and remember we draw a line, and we bring our first number down, which is a 1. And then you multiply.
4.
Good. So we take whatever the number down here is, and you multiply it to 4. So 1 times 4 makes
4.
4.
Negative 7.
And negative 7 plus 4 we add down, and that makes
Negative 3.
good. And then negative 3 times 4 is
Negative 12.
plus 2 makes,
Negative 10.
and negative 10 times 4 makes,
Negative 40.
which means that's 0 left over, which is exactly what we want. Because this n number, remember, is like your remainder, but we don't want a remainder. If something's a factor, it shouldn't have a remainder. Okay, so if we're writing this in factored form right now, this means that I have x minus 4, because this was a factor, and then this, you go 1 down from whatever your exponent was. So since I had x to the third, when I factored this one out, this now goes down to,
X squared.
so that's 1x squared minus 3x minus 10. Now you check to see, can this be factored further?
Yes.
Yes. And so what can it factor to be?
X minus 5 and x plus 2.
Perfect. X minus 5 and x plus 2. And so it says find all the zeros. So that means we'd be setting this equal to 0. And so I end up getting x equals what? What are the different values?
X equals 4.
Perfect. And so those are my answers. Okay, do we have any questions on that? You guys remember synthetic division now? Okay, on letter F, this 3 is actually supposed to be a negative 3. There was a typo there. Now, you notice on this one, they're telling you that one of the zeros is negative 3. So we don't take the opposite of this number. If they tell you something's a 0, that is the number that you're going to use for your synthetic division. So that's negative 3. Okay. And then we're going to do synthetic division again. And so I'm going to give you a minute here to try this one, to try to do it on your own. Just the synthetic division part. Okay. So the numbers should have been 1, 8, 9, and negative 18. We always bring down the first number, which in this case is 1. 1 times negative 3 is negative 3. 8 minus 3 is 5. 5 times negative 3 is We add those together, we get negative
Six.
6, and negative 6 times negative 3 makes a positive 18, which is my 0 left over. Now, when you're writing this in factored form, how am I going to write the parenthesis with x minus 3? X plus 3, good. Because it has to end up setting equal and equaling negative 3, okay? And then I have x squared plus 5x minus 6. Okay, now can this be factored further?
Yes.
Yes, and what is that factor to be?
X plus 6, x minus 1.
Good, x plus 6 and x minus 1. And then when we set all those equal to 0, my zeros end up being,
Negative 3, negative 6, positive 1.
good, negative 3, negative 6, and positive 1 are correct. Do we have any questions here? Okay, all right, moving on. Okay, so we have graphing. Okay, if you need help, you can go back and use this information. I'm just going to start on the examples and we're just going to talk through it, but everything that I'm saying is up here. Okay, so when we're graphing, there's a couple things that you want to start with first in the problem, and that is your degree. Your degree is dealing with how many exponents you have. This is an exponent of 2. This one has an exponent of 1, and this has an exponent of 1. So therefore, my degree would be 4. Okay, you also need to know what your leading coefficient is. Okay, if it's positive or negative. In this case, if you notice, there's nothing here in front, which means my leading coefficient would be positive. Okay, when you have an even degree, your end behavior, either both of them go up or both of them go down. Remember, odds are opposite. So odd degree, opposite directions, even degree, same directions. Since the leading coefficient is positive, that means that the right end behavior would be going up. And since it's an even degree, both of them go up. Or, yes. Okay? If your leading coefficient is negative, then the right end behavior goes down. Do you guys remember all that? Okay. So then the next thing is to find out each of my x-intercepts. Okay? So this one will give me an x-intercept of what? It's not hard. What's x minus 2 equals 0? 2. Okay, so we have x equals 2. This one will be x equals negative 1, and this will be x equals negative 4. So we can go to our graph right now, and we're going to put a point at negative 1. We're going to put a point at 2, and a point at negative 4. Everybody okay with that? Okay. Do you notice how right now there is not a point on the y-axis? Sometimes you have a point for x at 0. If you have a point for x at 0, you have your y-intercept as well as an x-intercept. But if you don't have a point on your y-axis, you need to find your y-intercept. Okay? How do I find my y-intercept? Very good. So if we want to find the y-intercept, we plug in 0 for x and we keep y. Remember, f of x is like y. So I'm going to write this as y equals, and we have 0 minus 2 squared times 0 plus 1 times 0 plus 4. What is 0 minus 2?
Negative 2.
Okay, so that means I have negative 2 squared times 1 times 4. Negative 2 squared is positive 4. Okay, so 4 times 1 times 4 equals
16.
So my y-intercept is 16. So that means we're just going to make a mark. We're going to call it 16, and we're going to put a point there. Okay, so the only information now that I'm missing is that we need to remember when something bounces and when something passes through. So do you guys remember when something bounces?
Oh, yeah.
If it's even.
Right,
Exponents.
exactly. So at 2, it's going to bounce. So right here, this is a bounce. Everything else is passing through. Okay, so if you want to put a P on those, you can. If you want to know that if I put a B, it bounces, but if I don't put anything, it just passes through. And so then we start here with our positive end behavior. It's a bounce, so that's where it just touches and goes back up. And so it goes back up, which works out because it's going to cross through the 16. Okay? Then it comes here, and since it's not bouncing, it just crosses through, turns around, goes up, and notice again it's not bouncing, so it's crossing through, and then it goes up and hits my positive end behavior. And so there's your graph. Hopefully you can draw better than me. All right, questions there? Okay, H. Next graph. Now this one is not factored fully, so we need to finish factoring it. So what can be multiplied to be negative 15 added to be 2?
Positive 5.
Good. X plus 5, and then we have x minus 3 and x minus 3. Now I'm going to rewrite this because what do you notice?
There's 2x minus 3.
Very good. There's 2x minus 3's. So I have x plus 5 and x minus 3 squared. And you can either write g of x equals this or y equals this. Okay, so that means here we have x equals what?
Negative 5.
-5, and x equals
Positive 3.
positive 3. Now, going backwards or whatever order you do this in, it doesn't really matter. What is my degree on this one? 3. Okay, so remember, like, this is 1, this is 1, and this is 1. If you went here, because this is an x squared, this is 2, and this is 1. So it'd still make 3, okay? And my leading coefficient, is it positive or negative? Positive. Okay, good. So since this is an odd degree, that means my end behaviors are going to go in opposite directions. Since my leading coefficient is positive, my right end behavior is going to go up, but my left end behavior will end up going down. Okay? We're going to make a mark here at -5, and then also one at positive 3. Do I know my y-intercept here? No. So we have to find our y-intercept. Okay? And so we write y-intercept. And you can go to whichever point you want to. If you want to go back to the beginning, I think it's easier to do y-intercepts when they're in factored form. Okay? And so we have y equals 0 plus 5, and then 0 minus 3 squared. So we get 5 and -3 squared. And we get 5 times positive 9, which makes 45. So my y-intercept is at 45. So we just make a mark up here at 45 and make a point. Okay, are there any bounces on this one? At 3. Okay, so if we go ahead and go and start here at the left, it bounces and it goes back up to 45, and then it passes through and goes down.
When is it, how do you figure out if it passes and bounces again?
So if you have an even exponent on a number, it bounces.
Oh,
If you have an odd exponent,
it passes.
Mhm.
Great. Thank you.
yep. Okay. I. And I know we're going a little bit longer than normal today, but really we have still at least 10 minutes, okay? But we won't take that long to do this, okay? You guys can handle it. All right. So, what am I going to do first?
Factor.
Factor. What do you notice?
There's a 4. You can take out a GC.
You can take an X out.
Good. And actually specifically,
X squared.
good. So we're going to take out x squared, and we get x squared minus 6x plus 9. I also noticed someone saying the degree. Did somebody say the degree? I thought I heard that. What's the degree on this one? 4. It's always your highest exponent. And if we end up factoring this through, even here you'd count 2 and 2, right? So my degree is 4. And what about the leading coefficient? Positive. Okay, good. All right, can this be factored further?
Yes.
To what? Good. X minus 3 and x minus 3. And so we want to end up rewriting this as x squared and x minus 3 squared. Everybody okay with that? All right. So when we're finding these x-intercepts now, this x squared is going to be x equals what? 0. And this will be x equals 3. Very good. So there's going to be a point at 0, and a point at 3. Do I have a point on my y-axis right now?
Yes.
Yes. So do I need to find the y-intercept? No. And if I did try to find it, I'll end up getting 0. Okay? And at 0, is there any bounces at either one of these?
Yes.
Both of them. Very good. Perfect. So both of those are bounces. I don't know what I was trying to say. Okay. Degree. Positive in behavior. What happens? Goes up. And since it's an even degree, they will
They both go
both go up. Very good. Okay, so we can start here. We go down, it bounces, it goes back up, turns around, comes down, bounces, and it goes back up. Okay, questions? All right, Jay. We have to write the equation. Okay, it's not that bad. Okay, first of all, y-intercept is going to be helpful for us finding our a value. Okay. Now, if you look here, this is a passing through point at -1, and this is a bouncing point at +4. So if we are going to write our parentheses, bless you, we are going to write this one as what?
X plus 1.
Very good, x plus 1, because we want it to make a -1. Since it's passing through, we know it's going to have the odd power. Okay? Here, this one has a bounce. This is going to be x what?
Minus 4.
And it's going to be squared because it has a bounce. Okay? This is all my factored form. Okay? And then I'm going to put y equals a. Because I don't know what my a value is. How do I find my a value? I use my point. Okay? I use my y-intercept. And what is this as an ordered pair?
12.
0, 12. Good. I also like to write here x and y to kind of help myself out. And so we're going to plug in these numbers in here and solve for y. Solve for a. So 12 equals a parenthesis 0 plus 1 and 0 minus 4 squared. Is everybody okay with that? So my variable is a. We're going to solve for a. Okay. So I get 12 equals, what is 0 plus 1? 1. What is 0 minus 4? -4. Okay? So I have a, and then I have 1, and then what is -4 squared?
16.
Positive 16. So I have 12 equals 16a, and what do I do?
Divide.
Divide by 16 and reduce. And we end up getting a equals
3/4.
3/4. So my final equation is y equals 3/4 x plus 1 and x minus 4 squared. Okay, last
I
one.
didn't actually have to do that one. I've never had to.
Okay, I would like you guys to do this one on your own, but we're not going to because of time. Okay, I'm going to put y equals, we know we're going to need an a here. My first parenthesis at -3 is going to be what? Is it going to be squared or not squared? Good. Next one is going to be at what?
X minus 1.
Good. X minus 1, squared or not squared?
Squared.
Good. Because it has a bounce. Good. Last one will be
X minus 2.
perfect. Squared or not squared?
That's good.
Good. Okay, what is going to be the point we're going to use in order to find a?
0, 3.
0, 3. Okay, 0 being my x, 3 being my y. Okay, and we got that from our y-intercept right there. Okay, so we get 3 equals a parenthesis 0 plus 3 parenthesis 0 minus 1 squared parenthesis 0 minus 2. Okay, we get 3 equals a times 3. What's -1 squared? Times 1, and we get -2. When you multiply those together, what do you get? -6a. We divide by -6 to both sides, and we find that a equals
Negative one.
-1/2. And so my equation is y equals,
Negative 1/2.
good, x,
3 times x minus 1 squared times x minus 2.
perfect. And that is your final answer.